Going in the water.
It has it. Now what?
Paprika, mustard,
The crab is so large
lemon
that
juice,
the snake can't
black pepper.
swallow it whole. Slowly and deliberately, the snake dismembers the crab.
In the last video, I'm not sure I really explained what I was getting at with the pictures, why those things are relevant and how they connect. When you're writing Python code, it's compiled into structured bytecode data. The interpreter loop reads that data and calls the C functions to perform the actual work. So those C functions have stood the test of time. Python's own internals, the opcode handlers, the object model, garbage collection, dictionary implementation, etc., they've been under active development for over 30 years now. You know, Guido started in 1991, Python 1.0 was 1994. It's now 2025. It's been a long time. These C routines have been refined and profiled for decades, but a lot of them are just wrappers around the C standard library. So Richard and Thompson get the general idea of Unix. Richard Stallman writes a C compiler and libc and all the other dependencies. And then Torvalds and other operating system providers provide more C APIs. And all those C APIs are used to perform the actual work. So this is the actual thing. The reason Guido's code and the Python code is wrapping the C code, been basically around for 50 years. The workhorse functions delegate directly to the C standard library or the POSIX APIs. You know, malloc, memcopy, free, qsort, fopen, those kind of things. And when you do async IO, it's just a wrapper for Linux's epol or similar on other platforms. So they're not Python specific. They're cool parts of the Unix C ecosystem. They've been tuned since the 1970s. So kind of 50 years of hardening, bug fixes, micro optimizations, support for every OS, every architecture. So when you do Python, you might do like A equals B plus C. What happens at the bottom of the call stack might be a memcopy and libc that's been in use since the days of VAX machines. You know, that takes up a whole room. So, I mean, these Python C functions that it runs have been hammered by countless real-world problems, edge cases, and security audits. I mean, it's refined through decades of profiling, micro-optimizations, portability fixes, algorithmic improvements. You know, in a continuous open-source, peer-reviewed development process. So it's going to be much more robust and portable than any ad hoc C code you write under corporate timeline pressure. You can't beat Michelangelo's David in terms of the art. Got into sculpting, finding the rock, making the rock, sculpting it, and producing this beautiful David statue. But most of the time, if you want an image of something, you can just take a photo on your phone. You don't need that level of time and attention. You don't have that time. You don't have the time to make a Michelangelo's David. You have to just take a photo on your phone. So with Python, developers don't have to reinvent the machine constantly. You can focus on the real goal, which is getting applications in front of customers quickly and reliably. I mean, C is better for low-level hardware stuff, right? Kernels, codecs, crypto, drivers. But for most apps, the speed of iteration is more important. You've just got to like find out. The problem's not really like the speed of the code. It's, does this code do what the customers want? Is this code adding business value? Is this application adding business value? And that's the speed of iteration is far more important. I mean, most corporate apps are either I/O bound because you've got networks, you've got databases, or they're just orchestration of different bits. Once your application works and it's good for the business and it's actually making money, then you can move hotspots to native code later. You can use NumPy and PyPy and C extensions and Python, things to speed up the hotspots later. But the main thing is just getting it done. And the Python, if I write the same app in Python and the same app in C, the C app might be 10 times faster, but the Python app's already out, released to customers, being used, while the C app might have used up all the budget and gone bust before it gets to customers. So that's why high-level programming is really important. But the advantage of Python over Java, JavaScript, Rust, Go, is that with Python, you still feel like you can access the C. There's not a huge layer of another platform hiding away the operating system from you. The knowledge is shared. You know something about Unix, you use it in Python. Learn something in Python, you can go back and look at the same thing in C. A lot of the names are shared that you couldn't really be higher level. It's almost English, but it's just a C program with an interpreter loop. Core types, lists, disks, strings, numbers are just C structs. You know, the functions that manipulate them are plain C functions. If you want to go into C and do an extension module, you're not crossing a big virtual machine or sandbox boundary. You're just calling more C. You know, Java runs everything in a JVM. To call C, you have to go through the Java native interface, which is verbose and brittle and marshalling and all this. In JavaScript, you're blocked to the JS runtime. You know, in Rust and Go, everything adds its own calling conventions and memory safety wrappers and Go routine scheduling. It's not just a PyObject pointer pass receive function. So with Python, you get the productivity of an ecosystem without being trapped. You know, when something is too slow or you can't do it, you just drop down to C and plug it straight in. It's a thin, flexible layer over C, which I find is a nice balance. I like the balance. But that's what I think. What do you think? Let me know in the YouTube comments and in the X Prozeth on X. See you next time.